Now guys, it is no doubt, and even I stated, that DevOps was the inspiration of MLOps, and MLOps inherits a lot from DevOps. Looking at how softwares are getting built and deployed in production at such a rapid rate using DevOps, ML community, which was already struggling in deployment, tried to leverage DevOps principles, but they are not exactly the same. MLOps at heart is DevOps only, but definitely it is more complex due to complex machine learning process, hence the differences between the two. So welcome to this lecture in where we will discuss the differences between DevOps and MLOps. The first and foremost difference lies in the team composition. In DevOps, the team comprises mostly of DevOps engineers. But in MLOps, team is more diverse in nature, having a variety of skill sets. MLOps team would have data scientists, ML engineers, data engineers, and of course DevOps engineers. In DevOps, the development is more linear. There are no development rounds of going back to same place again and again. Whereas in MLOps, processes are more iterative and experimental in nature. Data scientists play with different data, features, models repeatedly to achieve maximum accuracy in predictions. This requires more complex feedback loops. In DevOps, only the versioning of code is required. A change in the code alone can produce a new application. But in machine learning, different results can be produced by using different combinations of code, data, features, hence they too need to be versioned. In DevOps projects, the build time is entirely irrelevant, and thus the hardware on which it's done is also irrelevant. CPUs would be enough to do the job, so they are not compute intensive, we can say. But on the other side, training machine learning models, especially for deep learning, they tend to be very compute intensive. Larger models can take anywhere from hours to weeks to train, so they need extra hardware in form of GPUs. A subsequent difference owing to the same requirement of GPUs lies in automating the training runs. In DevOps projects, a build might take few minutes or an hour if it is a slow one, which means it is perfectly reasonable to trigger an automated build if someone makes a change in the code. However, in machine learning, since it can take days or up to weeks even for GPUs to train larger models, so it is not reasonable to train the model every single time there is a code change. However, there are techniques you can use like stage builds and stage training runs to get around that. In traditional DevOps, the continuous integration phase mostly comprises of testing and validating the code that is getting integrated. But in case of CI in MLOps, it is not only the testing and validation of code, rather it includes the testing and validation of data as well. Before training the model, you check if your data distribution is good, you don't have any skewed data, detect outliers, test for any null values, and etc. Now coming to continuous deployment, in traditional DevOps, CD phase is more of deploying a build package or service and make it available through a web service or REST API. But in MLOps, it is not simply deploying an offline trained model as prediction service, rather it is more of deploying a continuous training pipeline which on trigger can retrain and deploy the model automatically. This pipeline deployment adds more complexity and requires you to automate the steps that were manually done before. Then there is a difference in the intensity of monitoring. Errors are not only limited to error 404 bad gateway in MLOps. In general DevOps projects, we usually monitor the metrics like throughput, latency, CPU utilization, system idle time, etc. But in case of machine learning projects, along with these metrics, you have to keep an eye on the accuracy of models, production data drift, its features, these things. What makes MLOps monitoring more intense is the regulatory and ethical scrutiny on it. For example, your model cannot be gender biased or race biased. In pharmaceuticals and financial industry, there are regular government audits, so you need to be very careful. Unethical or wrong output consequences can be financial, but maybe even more prevalent is the loss of trust and reputation, and the worst is legal actions. So you have to continuously monitor if your model is aligning with all those regulations. Because at the end, it's not you or your code which is delivering. In DevOps application, whatever code you write, your application will behave strictly in that way only. So it's kind of less risky. Less risky as in your application will adhere to the government laws. But in machine learning, even though you train the model, but still the final output is getting provided by a model on its own. And those outputs are vulnerable to many factors like change in data patterns, customer behavioral changes, and whatnot. So it's more risky than DevOps applications. Continues the above point, there is always a need to retrain the model. Where DevOps is only continuous integration and continuous delivery of software, MLOps has added one more entity of continuous training of the models. Models degrade over time, they are impacted by changing data profiles, and it is possible that as soon as you go into production, the model starts behaving abnormally instantly, which is though very rare, but definitely over the period of time, as a new pattern of data flows, your model will gradually start derailing from what is expected from it. Therefore, add a step of continuous training in the life cycle, which can trigger the retraining of model either on demand or when new training arrive or on schedule, which we already discussed.